Children, earlier we have seen the experiments of Faraday and Henry on electromagnetic induction. And based on those experiments, Faraday formulated some of experiments. So in this, we are going to discuss about Faraday's law of electromagnetic induction, relation between induced EMF and current, and the problems based on laws of EMI. First, the laws of EMI. First law is whenever the magnetic flux linked with a circuit changes and EMF and hence current is induced. However, it lasts only so long as the magnetic flux is changing. We have seen in those experiments current by magnet, current by current, and current by changing current. So it is the first law condition that when an EMF is induced, and second law the magnitude of that induced EMF, and that law says the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linked with the circuit, and that's the magnitude is EMF equal to negative of d phi by dt, or we can say negative of phi 2 minus phi 1 by t. For n turns, it will be minus n d phi by dt. The negative sign indicates that the induced EMF in the loop due to changing flux always opposes the change in flux. In other sense, we can say the direction of induced EMF is such that it always opposes the change in magnetic flux linked with the circuit. And in details, we will learn in Lenz's law about its direction. Now, if we consider a coil of n turns and resistance R, the magnetic flux linked with its turn changes by d phi in time interval dt. Then from laws of EMI, what we can say induced EMF E equal to negative of n d phi by dt. Now we know current equal to V by R. So induced current I equal to induced EMF by R, and its value will be minus n by R d phi by dt. Now the charge, electric charge flow due to induced current Q equal to I dt, or if we substitute here the value of I, the magnitude here, that will be n by R d phi by dt into dt. So this dt got cancelled. It is n by R into d phi. And what is d phi? It is the net change in the magnetic flux. Now a problem. See here, a square loop of side 10 cm and resistance 0.5 ohm is placed vertically in east-west plane. A uniform magnetic field of 0.1 Tesla is set up across the plane in the northeast direction. The magnetic field is decreased to 0 in 0.5 second at a steady rate. Determine the magnitudes of induced EMF and current during this time interval. Here a diagram is a plane which is placed vertically in east-west plane. So first here, what is the initial flux? Initial flux we know be a cos theta, and here the magnetic field at in the north east direction, so it forms a angle 45 degrees. So its value will be 10 to the power minus 3 into 1 by root 2 Weber. And see another given, the magnetic field is decreased to 0. So what is the phi 2? Final magnetic flux, that is 0. So change in flux, we can say its value will be phi 2 minus phi 1, and its value will be minus 0.707 into 10 to the power minus 3 Weber. And time interval here, that is given 0.5 second. So induced EMF equal to minus of d phi by dt, and we will get its value is 1.414 millivolt. And finally resistance is given, so we can find the induced current by using the formula E by R. Some of the question you may try at your own. Thank you.